It is my pleasure to give a talk at AI and the Next Generation Communication Forum. My name is Albert Guo from Realtek. I'm leading the automotive Ethernet product line, and I've been in Ethernet industry for more than 20 years and also devote myself in automotive industry for more than 10 years. Today, I'm going to spend some time to talk about cybersecurity for in-vehicle networking. And the agenda today is going to cover the mega trend of the industry and also how the mega trend will affect the revolution of EE architecture, and also why the cybersecurity is important for new generation vehicle, and what are the major challenges and possible solutions for cybersecurity. In the end, I'm going to give you an example of the current vehicle cybersecurity measures. This is a classic Mercedes Sports 30s convertible SL series. And you didn't see much electronics device. And the only infotainment system available is the radio, AM/FM system. And mostly they are mechanical device. And that's why you don't have to worry anything about cybersecurity. And that's why I say this application is more secure. And this is a brand new model called EQS. They are going to launch next year. You can imagine, you can enjoy all kinds of service by connecting your mobile phone to the vehicle. And you can even do shopping when you drive in a car. But this implies also a lot of communication from in-vehicle to the outside world. That means a lot of potential threats are exposure to the risk. So that's why I say more application is less secure. And I think a case, now let's see the mega trend. Case is no longer new to my audience. So the people want your car to be more connected and to be more autonomous and able to be shared and also more electrified, energy saving. But to echo, to respond to this mega trend, the EE architecture within the vehicle is now having a big revolution. So moving from the left to right, in the past, you can see different ECUs, different functions, they connected to each other. It's more like point-to-point connection and no networking concept. That imply a lot of ECUs and also a lot of harness. Today, in the middle, you can see there is a gateway connected through Ethernet to different domain controller. And by this approach, you can see the number of ECUs and also the harness, they are largely being reduced. And on the right-hand side, if you want to further reduce the cable length, and you can see some few of the zonal gateway are reused within the vehicle. And the different domain functions, those small box, they connected to the central computing platform through zonal gateway. And with this architecture, the hardware, those computing platform, those zonal gateway, they are largely being reused. And they enables the so-called software-defined car concept be possible. That means hardware reuse everywhere, cover different variant, and the OEM, they are able to do differentiation by update the service to the software, to the central computing platform only through the OTA. And this is the whole new business model. And with this business model, the end user, they are able to enjoy, brand new driving experiences every time they update their firmware software. And from the OEM side, every time when they provide this update of service, they are able to collect money. That's why I say that's a new business model. And that's a perfect work. But still, there are some risks. Look at the architecture on the right-hand side. Once the hacker is able to hack into the system, contrary to the architecture in the middle, some safety critical application, they are separated. But now they all mixed together. So let's look at this concept. Say in the past, safety concerns about human life, and the data is about data records, like code records, PVR records. But with the higher level of autonomous driving, these two concepts, they mixture together. So I can say there is no safety without security. So that's why cybersecurity is so important. Now let's talk about what are the major challenges of this cybersecurity. I think the first one is the complexity. There are more than 100 million lines of code in modern vehicles. That means, you may create many potential risks for the hackers, many entry paths. So the quality of the software, how to ensure. And the second one is the long lifetime persistence. Once the car has been sold, the lifetime is 15 years. So the hacker, they may attack the vehicle, say 10 years later. So how to prevent from this kind of threats? The third one, as I introduced the EE architecture, they convert from closed system to open system. So many interface, many connection to the outside world. This also create even more worse situation for those cybersecurity. And in the end is the vulnerability in supply chain. This means the supply chain is so long. So from OEM, from tier 1, tier 2, and even dealers and even cloud service provider, but those long supply chain, how to ensure the cybersecurity, they have consistent measures. So those are the major 4 challenges. And luckily, we also see some possible solution in there. The first one is to have a reliable coding style. Misra already did a good job. We can have another page to introduce this. And the second possible solution is a monitorable and updatable EE architecture. And they are able to deal in the threats from time to time to dealing with these persistent threats. The last one is for the long supply chain and for this open system, how to have a consistent cybersecurity measurements through the whole supply chain. I think that we need standard and regulation. So the reliable coding style, I think it is proposed or organized by Motor Industry Software Reliability Association. It provides a clear guideline for the programmer to ensure the quality of the software. And that means safe, reliable, and portable, also secure. So this is a MISRA. The second would be monitorable and updatable architecture. I think from the left-hand side, within the vehicle, you can see different ECUs. So for each ECUs, they have a IDSM, the so-called IDSM, Intrusion Detection System Manager. They are able to collect the potential event or threats and forward those events to the IDSR, as shown here, blue box. It is IDS reporter. And those events then forward or report to the remote cloud server, VSOC, which is Vehicle Security Operation Center. I think they are able to do preventing, detecting, analyzing, and responding to these cybersecurity incidents. So I think some adequate measurements or countermeasures need to carry out, and they are able to update those cybersecurity measures through the OTA update here. So with this approach, with this architecture, the OEM, they are able to ensure the capability to do this long-term monitor and persistent to those threats. Okay, and the last one is standards for cybersecurity. There are many standards and cybersecurity, or in regulations, but I think the only two worth mentioning here is the first one, WP29. I think this is provides a regulation for the government to regulate OEMs to ensure the whole product life cycle they have a cybersecurity management system, CSMS here. And once the OEM, they implement and got certified by this CSMS, the government is then able to approval the launch of new vehicle by this VTA process, the so-called the vehicle type approval. So this is WP29. Respond to the regulation defined in WP29, ISO 21434 was developed by automotive industry, and they are specifying the product, the whole supply chain product development cycle, what kind of process and activity involved. They also need to take good care of cybersecurity management. So it's about process and activity involved in design the product. And by carrying out this process, that usually it will have this so-called Tera. It means threats, analysis, and risk assessment. So with this Tera analysis, the risk, the threats can be identified, and the countermeasures need to carry out. So with this approach, the industry is confident that they are able to comply to this WP29, R155 especially. And when you carry out this Tera, unavoidably, some standard or some implementation technology were involved. So that is, for example, IEEE or IETF. So these two standard body, they also have some industrial standard, and usually it is about encryption, decryption, those technology. Okay, let's deep dive into the Tera. So I think there are six threads, common threads listed on the left-hand side when you perform the Tera process, including spoofing, tampering, repudiation, etc. And on the right-hand side, these countermeasures including authentication, integrity, or confidentiality, But on top of that, monitoring is very important. Monitoring means the capability to monitor the whole product life cycle. What are the risks? What are the potential? And they are able to react in real time. So this is also very important countermeasures. So don't forget this. We are going to use this kind of concept later. And now I give you an overview, say a matrix of cybersecurity measures. from ISO OSI 7-layer of protocol point of view. And as you can see here, for a different layer of the OSI, in the first, the threat analysis must carry out. For example, this design of service could happen from layer 2 to layer 4, and also in layer 6, layer 7. And for some spoofing threats, they can also happen also layer 2, layer 4, layer 2 to layer 4. And the layer 1 was mentioning is this software configuration tampering, because the hacker, they may want to manipulate the flash of the gateway, and they are able to manipulate the traffic. So this is also some potential risk involved. And once the threats been identified and the counterpart of the countermeasurements were carried out, for example, as I mentioned previously, some may need authentication, some may need availability, and some may need integrity check. And on top of that, on the right-hand side, threat monitoring. It covers from layer 1 to layer 7. And in the end, the involved technology also introduced. So for example, this design of service prevention and also the VLAN, ACL, they are developed to counter the design of service threats. And as I said here, DPI, IPS, or intrusion detection, those technology also developed to deal with the threat monitoring. And on the other hand, from the layer 1, you can see here, so there is a so-called secure boot to ensure the integrity of the flash when you do the boot up. Okay, then in the end of the session, I'm going to give you one example of the in-vehicle security measures. On the left-hand side, you can see this is a very typical domain control-based EE architecture. So there is a gateway in the middle connected to different domain functions. For example, infotainment, T-box, ADAS, or diagnostic. And we are now going to do some threat analysis for different ECUs. For example, for the gateway, I think there are some software configuration tampering threats could happen, as I said, like a secure boot. So you may need this integrity check, and also the secure boot technology will apply. And for the rest of the ECU, located in different domain, here, here, and here. Okay, as you can see on the right-hand side in the middle here, snooping, tampering, design of service, or spoofing, also persistent threat. I think those kind of threats can happen everywhere. That's why those countermeasure, cybersecurity countermeasure need to carry out. And this technology, for example, TLS and IPsec, MACsec, they will be carried out in the near future within the vehicle, and to deal with this snooping and tampering threats. And also for this threat monitoring, I already mentioned IDS, IPS, DPI will carry out almost everywhere. So this gives you an overview of the current vehicle cybersecurity measures. So to the end, conclusion today, I think the first one is the zonal gateway plus central computing architecture. It enables the software-defined car, which is necessary for the whole new business model for OEM. And the second one is the importance of cybersecurity. So there is no safety without cybersecurity. The third one is, I think with the introduction of regulation and the industry standards, I think they provide a very good guideline to build a process management system and to ensure the cybersecurity measures can carry out in the whole product life cycle. And in the end, we also introduce those technology being used in Tera, like threat analysis and the countermeasures, and also the technologies being used were introduced. If you have any further questions, you are welcome to contact me. Thank you, and enjoy the rest of the session.